Section 10.4, Other Angle Relationships in Circles. So at the end of this lesson, you should be able to use angles formed by tangents and chords to solve for missing measures. So far we've talked about a lot of different theorems that have to do with angles and chords and lines that are associated with circles, and today we do have some more. And the first one that we have has to do with tangents and chords. So if you have a tangent, like this one, and a chord that intersect, then they're going to form two different angles. And the measure of these angles is going to be 1/2 the measure of the intercepted arc. So here, angle 1 is going to be the half the measure of arc AB. And as for angle 2, angle 2's measure is going to be half the measure of its intercepted arc. So it's going to be half the measure of arc BCA. So let's take a look at an example of this. We're given that QR is a tangent, and we're also given a chord SR, and we're asked to find the measure of angle QRS. So angle QRS is this angle here, and according to our theorem, that this is going to be half the measure of its intercepted arc. The intercepted arc is this one here. So we're going to want to set up an equation in order to solve. We can start by saying 5x minus 10, and it needs to be related to 8x plus 32. Now, 5x minus 10, if we multiply that by 2, it'll have the same measure as its intercepted arc, because this is a bigger measure. It's larger. So we're going to multiply that by 2. In order to solve, we'll just distribute, and we'll have 10x minus 20 is equal to 8x plus 32. We're going to go ahead and move this 8x to the opposite side. So we will say that we have 2x minus 20 equal to 32. Add 20 to both sides, and we'll have 2x is equal to 52, and x will be equal to 26. Now the question is asking us to find the measure of angle QRS, and we know the measure of angle QRS to be 5x minus 10. So now that we have the value of x, we can substitute this in to solve for the measure. So 5 times 26 minus 10, and 5 times 26 is 130, and 130 minus 10 is 120. So we know that the measure of angle QRS is going to be equal to 120 degrees. We also have the situation where you might have two chords that are intersecting. And if two chords intersect in the interior of a circle, then the measure of each angle is 1/2 of the sum of the measures of the arcs intercepted by the angle and its vertical angle. So let's talk about this a little bit more. If I have this angle 1, its intercepted arc is DC, and its vertical angle's intercepted arc is AB. So if I was wanting to find out the measure of angle 1, I'd have to go ahead and add the measures of arc AB plus DC, and then divide those by 2, or take 1/2 the sum. Also, if I wanted to find out the measure for angle 2, its intercepted arc is BC, its vertical angle's intercepted arc is AD, so I will need to find the sum of BC and AD, and I could divide that by 2. Let's take a look at an example. So here we're asked to find out the measure of angle x. Well, angle x is formed by two chords intersecting in the interior of the circle, just like our last theorem. Angle x has an intercepted arc of GJ, which is 150 degrees, and its vertical angle's intercepted arc is FH, and so that's 136 degrees. So I know that the measurement of, we'll call this angle G IJ is going to end up being the measure of arc GJ plus arc FH divided by 2. So we can substitute in the values and what we're trying to solve for. So x will be equal to 150 plus 136 divided by 2. So this will be 286 divided by 2, which will be equal to 143. So we can say x is equal to 143. One last set of theorems, and this has to do with tangents and secants. So a tangent and a secant, two tangents, or two secants. Now, even though it looks like three different theorems, they're really all going to be similar to one another. So if you have any of these scenarios and they intersect with the exterior of the circle, then the measure of the angle formed, angles 1, 2, and 3, is going to be 1/2 of the difference of the intercepted arcs. So the intercepted arcs that we have for this situation, we have this as one of the intercepted arcs, and this one is one of the intercepted arcs. For angle 2, this PQR is our larger intercepted arc, and our smaller intercepted arc will be arc PR. And then arc XY is an intercepted arc for angle 3, as well as WZ. Now the order that you're going to want to subtract them in needs to make sense. So we'll always do the larger minus the smaller because we don't want to have a negative measure, because it's not realistic for us to have a negative degree measure for an angle. So what we will say is angle 1 is going to be equal to the measure of arc BC minus arc AC. This angle 2 is going to be equal to the measure of PQR, and we're using 3 because this looks to be a major arc, minus PR. And the angle measure 3 is going to be found by taking the measure of arc XY minus the measure of arc WZ. Let's take a look at some examples. So here we have to find the value of x, and we have a couple different situations. But both of these are like our last few theorems, which means that our angle measure will be equal to our large arc minus our small arc divided by 2. And remember that both of these are your intercepted arcs. So let's first try to find our intercepted arcs. For our first one, this is our larger intercepted arc, and LP is our smaller intercepted arc. And we're going to want to set up an equation. Following this format, our angle measure is actually given to us. So we'll say 58 is equal to, my large arc is the one that's unknown, so that's x, minus my small arc, which is 64 degrees, divided by 2. So in order to solve, we'll need to multiply both sides to get 2 out of the denominator, which will cancel on the right-hand side. X minus 64 will then be equal to 116. Looking at this, then, we could say that if we add 64 to both sides, we'll end up with 180. So the measure of x, which is arc LMN, is going to be 180. Our next example works the same way. We just have a different unknown. In this case, our unknown is actually the angle measure. So we'll say x is equal to my large arc, 68, minus my smaller intercepted arc, which is 24, divided by 2. This one we simply need to simplify in order to solve. 68 minus 24 will leave us with 44 divided by 2, which will be 22. So really these theorems are more so formula based, and if you know the formulas and the relationships between the angles that are formed and the arcs that they intersect, then you'll be good to go. And that's all that we have for this lesson, so it's time for our joke. And our joke is, what time was Brian's dentist appointment? It was at 2:30.